Hello students, Paul Austin here. We're taking the next section on vector and bitmaps in Python with turtle graphics. And just to look back on here, we're looking at this one unit. We'll actually get into those Boolean expressions a bit more, looking at the nested loop and looking at how we're doing a picture pixel by pixel. So we're not calculating the endpoints of vectors that we're drawing. We're actually going to paint each dot. We're going to come up with a calculation of what those should look like. Here's our Python code we picked up from the last unit. If we run that, we're going to see we've painting each pixel as a dot. Now, on a computer screen, those would be rectangles, but the turtle graphics is painting a dot, actually a circle. So we'll go ahead and quit that out. So instead of painting everyone unconditionally, we would say we're going to add a function. Say if test pixel, pass in the X and the Y location. If that's the case, then we're going to go to that location and paint the dot. And now we'll go ahead and make the function define test pixel X, Y. And for our first picture, we'll do a circle. So if the pixel is within a certain radius of the origin, we'll turn it on. If it's not, we'll ignore it. So radius equal to x squared, and I'll just do x times x plus y squared. There is a math function for doing power. I added the math module since last time. So math.sqrt square root. For a simple equation like this, it's pretty common not to do the extra parentheses, but make it extra clear here. Those, of course, would have been done in that order. Now, it's pretty common to see an if statement like this. If radius type head less than, we'll just use the size of our graph. Return else false. So go ahead and run this code. Let's see what we see on here. There's our circle. Now, when you look at code, it's not uncommon to see something for a Boolean function where you'll see some case, if this, return true, else return false. That's a style. Well, you can basically shortcut that. And shorter code usually is more legible. So in this case, we're just saying return radius less than size. Because radius less than size is itself a Boolean expression. So we don't have to use the if else to return. Don't need the colon then. If we run that, see that circle. Now we've got a function that is being evaluated for each pixel. And if we change it, maybe we say greater than size, instead of it painting the inside, now we're painting all the areas that is greater than the radius of that circle. Another nice piece here, you notice it's all nice symmetric. One change I made since the last time we looked at that code is I went from minus size to size. I added 1 to each one. Otherwise, we'd have only gone to 99, and the picture wouldn't have been as symmetric. All right, that's the next step. We're using a case of returning a Boolean expression instead of using the if, then else. And we are iterating over each pixel and calling the function for it. This actually is a way of what matrix processing, or what happens in GPU units, is there actually is a processor that can execute for each pixel.